All right, Martin, Jan, thank you very much for inviting me here to Dresden at Saxonia, talking about E-Graphenes. Many people ask themselves, what are those? We will lift the secret in a bit. But before, let's talk about how you founded the field of battery innovation. Martin, you want to start?
Yeah, for us, it was really a combination. I mean, we're working with graphene for many years. Graphene has been around for many years. I guess we will talk a little bit more about that in a few minutes or seconds. But we've worked with a lot of customers in the past, and the batteries were really those where we've seen multiple use cases and constantly good feedback. And obviously, as a company that wants to grow, we needed to find an application that also scales, and the battery just was a good fit for us, and that's why we really decided to focus on that. Yeah.
Mm-hmm. Okay, Jan, what was your entry? Or maybe I reframe the question a little
Yeah.
bit. So that's kind of the Saxonia entry into the battery
Yeah.
field, but maybe also asking personally your path into the field of batteries. So you're coming from material research, right? And from the field of graphene research.
Yeah.
Maybe you can elaborate on this in a second, because this is kind of an extensive story I heard. But Jan, you entered Saxonia a little bit later. Was that your entry into the battery field?
Essentially, it was because I entered the company at the phase where we had all those experiences and data from multiple customer projects and applications. And we really wanted to decide where we want to focus our efforts, where we want to build our go to market for the company, because the material was ready, feedback was great. And then we looked into many applications and we finally decided that battery is great because of the performance, but and the scaling potential, as Martin said, but also the timing was right.
Mm-hmm.
And that was really about last year investigating and then finally deciding to say we want to enter the market. And it was also my first time. And that's always interesting in life when you start with something and you can really go into a new field, learn about the market, about the players in the market. And so far, that was been also an easy story in terms of it's super easy to connect with people, that people help guide us through all the field and how the industry is working.
Yeah, so you went heads first, kind of.
Yeah.
Yeah, leading up to that moment when you entered, I think there was a story before, leading all the way back to 2016, 17.
Yeah.
Maybe Martin, you can elaborate a little bit, and then with that also explain what Saxonia actually does.
Yeah, sure. So I'm a chemist, and I did a postdoc in the university, and a new topic was coming up, and that was basically I got an offer to lead an industry project with a company that was trying to produce graphene. So that was my entry point back in 2016 or 2015, so almost 10 years ago. And so I've always worked in industry projects. Basically, I really like the hands-on stuff where I can see what it's for, and really not just fundamental science. And eventually, pretty much at the beginning, I already realized that graphene is not graphene. So like it's a family of materials, and the properties that you can have in the material really depend a lot on the way that the material is produced.
Yeah. So if I may intervene there really quick, what is graphene? Can you
Okay.
explain that in a couple of layman's
sure.
terms?
Yeah, you always forget that maybe not everybody knows what you are talking about. So graphene is basically a very, very thin carbon material. So it's a carbon structure in two dimensions. So everybody knows graphite, right? So graphite is the stuff that you have in your pencil, and this is a layered material. So if you are writing with your pencil, you're basically separating graphite platelets from each other, and that's how you get the black color on your paper. And eventually, if you go that like all the way down to the atomic level, what you end up is a layer of graphene. So essentially, graphite is, you can imagine graphite is a book, and then each individual page is a layer of graphene. And what we are doing is basically taking graphite and taking this book and ripping out the pages in a way.
Okay.
Yeah.
So and why is that necessary or advisable to do? What do you gain from that?
So obviously graphite is an interesting material which has interesting properties. For example, it is conductive, but the magic really happens when you go down to the atomic level and really to few layers or few pages of this material, where you find a material that is like extremely electrically conductive, extremely thermally conductive. It has barrier properties, so it's impermeable for even hydrogen and stuff like this.
Really? Oh.
And also has a very high mechanical strength. So I mean, there has been a lot of buzzwords around that, so you have to be a little bit careful not to oversell, because it's been a big hype in the last year. So the basically Nobel Prize was 20 years ago, I think, or Discovery, I'm not sure. I think the Nobel Prize was 20 years ago, roughly. And so there's been a big hype about that, and a lot of overpromising, and also a lot of disappointment, unfortunately. So we have to deal with that as well. But yeah, it is an interesting material for sure.
Okay, so then you stumbled across graphene in your research back then. So how did that evolve into the idea on providing a stellar material, an additive for batteries?
Yeah. So what I realized early on, I already said that it's like graphene is like a family of materials, and the properties really very much influence the properties are very much influenced from the production method. So there's two production methods that have been already at scale back then. So one was a purely mechanical process and one was a purely chemical process. And in one case, you could get a material that had very good properties in the mechanical case, but the material that you get, or the graphene that you get, is incredibly hard to process because it tends to stick back together, basically like wet paper. You can imagine, like they glue together, and also the flakes are very small. So imagine you want to exfoliate the pages of your book, you throw the book into a kitchen blender, and that's basically a good analogy there. So you get wet, small sheets of paper that stick back together. So processability was horrible. And then in the chemical process, you are basically oxidizing the graphite. So you're introducing a lot of defects, but those are destroying the properties. They make it very easy to process because this oxidation, it's like rusted graphite, you can say. It makes it easy to process. But yeah, the properties are lost because of this. And then maybe it is like I more or less stumbled into it, let's say. So it's probably one of these cases where everybody says, oh, it doesn't work, but then somebody came who didn't know and just did something different. And so the group that I was joining there, they had already experience in an electrochemical process to exfoliate the graphite, and I basically built on that foundation and knowledge and developed the process that we are now using in Saxonia, which is combining an electrochemical exfoliation. So we are separating the graphene layers in the graphite, but at the same time use electrochemistry to add little functional groups on the surface. So we are not destroying the material, but we are rather adding functionality without destroying the other properties. And that's what really stands out in our case. And so that was maybe 8 years ago.
So already this discovery that you can, by adding functional groups, remain product properties, but also keep the processability.
Yeah, I mean, I didn't invent that concept. So adding functional groups is a typical way to make materials easier processable. But all the processes that have been out there and that are out there right now that I've seen are really like incredibly difficult to scale as well. So our process combines this benefits of having high quality, having high processability, but on top of that, it's also very scalable and rather cheap.
Okay. What are the product characteristics? So you are developing this now, or developed it already? I mean, it's, from the outside, it's noble that it's an additive, but can you explain, like, how does it work in the battery? Like, where is it placed? Is it mixed with a powder up front and then included in the slurry? So where does your innovation step into the value chain of battery production?
So I would say the most common use case is really adding it to the slurry, let's say, as a conductive additive to be replacing carbon black or nanotubes, where we also have the most experience, let's say, in terms of customer feedback, and we really see quite a lot of benefits there in terms of cycling speed, cyclability itself, energy density, because you need much less loading, for example, compared to carbon black, and all these things. But there's multiple use cases in the battery. So there's also the possibility to use it as an interface material. Because of this barrier properties, it can really like protect the current collector, for example.
Yeah, you showed that during our tour, right? With the spray
exactly.
coating
This is
demo.
Yeah, and then what else do we have? We also, I mean, basically also in battery concepts that are not this typical battery that you find in the car, but for example in redox flow batteries, where you use very special separators that are like ion specific or ion conductive membranes. We've also seen great improvements with just coating these membranes with graphene, for example, to increase like the power densities of these batteries. And yeah, there's really a lot of application, and that's also one of the fascinating things about graphene, is that it combines all these 4 properties that I mentioned in the beginning in a single material, and then really, it can benefit a lot of different applications.
Okay, I understand. And if we look at the current market and the development on Saxonia right now, maybe you can also add on onto this from the entrepreneurial point of view. So I understand you that you have the material in place that is basically fully developed now, also in testing and validation by customers. And you are also able to scale this now to an extent. I understand gigawatt scale probably not yet, but at least like megawatt, like serious production lines you can already supply with, correct?
We have a customer now that we work with since 3 years, I do think, and they have done extensive R&D with our material, and they are now entering their production ramp up. So we are hoping to sign an offtake agreement by this month. So this will be the first customer then going into the direction of serial production for battery. And on our own ramp up story, I do think we have now about 30 tons of dispersion capacity. So there is plenty of material available per year for nearly all customers in different stages. And we plan to scale that within the next years to a more industrial scale that we can also deliver on gigafactory scale, because in the conductive additive case, this would be needed. That's the plan.
Yeah, maybe you mentioned a couple of tons. Generally, people, when they're talking about battery materials, talk in the order of magnitude of kilotons or even beyond. Maybe you can explain that really briefly, that tons already means a lot.
Yeah. So in our case, which is the main use case, as Martin described in the conductive additive case, probably the average amount of material that you need bringing it to the cathode or anode is like 1% of that cathode material as in conductive additive with E-Graphene. You need about 3 to 5% of that with carbon black. So that shows the benefit when you bring in E-Graphenes. You can save a lot of material, can bring in more of the active material, so more reach for the car, for instance. So we need less material to achieve also a better performance. We can even decrease costs in the overall battery. And so we don't need to produce the amounts of material that a typical gigafactory needs for a whole battery, but just a tiny amount. That's why we are an additive.
I understand. So talking about the performance characteristic, and you, either of one who is first can answer that question. Of course, you mentioned the range of a car. That's the ultimate goal, right? The second goal is C-rate capability. So what is the charging speed? Since you're enhancing the conductivity, can you explain how you alter those 2 metrics through the addition of your additive?
Yeah, so obviously every battery chemistry and battery is different. There's a lot of different chemistries and also formats and formulation possibilities, and generally lithium ion, solid state, all these kind of different things. So it really depends on the specific use case and the specific chemistry. But we have seen things like a factor of 3 improvement in the rate capabilities at higher like charge retention, let's say at these high C rates, so you can charge the batteries much faster.
So higher C rates, you mean like 6C, or what range are we talking about?
I mean, that's what I mean, that it really also depends on the battery chemistry.
Okay.
Then. So in some cases we have seen like 20C, and it was still like at
Okay.
60% of the like theoretical capacity. And in other cases it's like 60 or something like that. So it really depends. It also depends on how you integrate the graphene. So that's why we also try to work together as closely as we can with the customers, not just throw some material over the fence, but really co-develop together and optimize the formulations. And that's also one of the special capabilities that we have, is that we can really customize the material and the formulations towards the customer process. So we can really adapt to that, and without changing the hardware, because like all the magic, let's say, and the customization is happening in the electrolyte of our process. So it's not affecting the machinery that we use to produce the graphene, but we basically just change a recipe, and then we get a slightly different graphene that might be really the best fit for the specific customer application and process that they already use. So we're really targeting to offer drop-in solutions that don't require any modifications on the customer end, really.
Okay, talking about the customer, I think opens up the opportunity to talk about the market and this whole network. I mean, that's the reason why I'm building this battery expedition campaign and touring Europe right now. And can you shine light a little bit from the entrepreneurial point of view, how your innovation is taking up the discussions with the partners or the customers, but also with the partners and investors also? So would you say the European ecosystem is working? And maybe we kind of go through all those different stakeholders there. And you can say a little bit on where the challenges are and the potential lies, I guess.
So like maybe starting at that point, why also we decided for the battery market and not any other also interesting application for E-Graphene, is that in Europe, which is our like home market, and in North America, there is a momentum that's driven by the wish for independence from the Asian manufacturers, and really the goal to establish a local value chain, right? And I do think that timing for us is perfect, because we do have a material that works. We can scale that up. And we bring some interesting technology also to the market with our production approach that allows for local production. So local production very close to a gigafactory here in Europe, but also in North America, potentially also in Asia. Something that probably no other additive manufacturer can do. So they always need their kind of on-site production or their local centralized production. And we really have a modular concept where we want to bring our production as close as possible to the customer, reduce logistic costs, reduce supply chain issues, allow for solvent recycling. And like this is a great fit where we see a lot of positive feedback from customers and partners that we discuss, because those are kind of headache from the supply chain perspective, and from regulations that come up both in Europe and in North America. This aspect of local production is super important, and so we really feel that we fit in and have a very good timing with the material and the production approach.
During our tour, you used a word that I find inspiring, like autonomous production, right?
Yeah. That's the goal.
Can you explain that, or one of you would explain that really quick? Like, what is the like the concept really is, the practical concept that is behind this? Because saying like, we're going on site, we're going decentralized, but what does it mean? Like, how should I envision this if I want to become your customer?
Yeah, so the idea really is that we leverage the benefit that we have, that our production really has a very small footprint, and it's apart from, I can call it again, the magic that happens in the electrochemical process. It's all the standard equipment eventually that can be combined and can be bought off the shelf. So there's very little technical risk at this point, I think. And the challenge that we are facing next is really combining different types of equipment, automated. But then there's not really anything that would keep us from also letting it run without humans interfering in it. So in this kind of approach for having an autonomous system that is very compact, so it can fit inside a container, a shipping container, for example, is something that it's just too big of an opportunity than for us to not do it, I would say. And
Sounds good.
yeah.
And I saw the process running, so it appears like it's just doing its job.
Yeah.
So
Exactly.
I see the point. Okay, gotcha. If we look at this from the startup perspective, so your entrepreneurial journey and where you're at right now, I think you just made a big step on this way, but I don't want to explain it. Please do so and give other peers of our industry an understanding how such a success story can unfold.
Yeah, maybe I can start. So we created it basically as a spin out of the university, and in the first few years really relied on early customers like who wanted to investigate new materials and do innovation and things like this. So we always, like from the beginning, we got some revenue, which I think is a good signal always, if especially if it's repeating. And obviously also public funding played an important role. So we were part of a big EU initiative, the Graphene Flagship. I don't know, maybe some people have heard about it. And this really allowed us also to do this first step in scaling, let's say, from a beaker approach in the lab to like this more or less automated system that we are using right now as a pilot. And this took quite some years. I think everybody who is working in the material space is aware that material innovation needs time, and it's like, I don't know how many years it's been between the first bakelite telephone, let's say, the first polymer that was introduced to the market, and now where we cannot imagine a world without polymers and plastics around us anymore. So yeah, it takes time. And for us, I think this is like also important for other startups maybe, is that you really, when you reach the technological maturity, then as a scientist, like from my personal perspective, you need to like look further and also think about like how do we scale this, and what kind of competencies and expertise will we need. And that's why also like how Jan and Rudy, who cannot be here today, joined the team. And because you just need like multiple competencies combined. I think that's very important. And then maybe you can say a little bit about our recent journey.
Yeah, but just to like the need in the company was to bring in this commercial and business perspectives to take our material and the great properties and tell it to our customers, and even more customers have this decision on a core and focus market, which is now batteries. And yes, obviously, we want to scale production technology, so we need also investor money. We cannot only live with public funding and customer money at the beginning. And so we talk to many people who are candidates to support both with money and expertise. And we are super happy that we finally found people, but also a company obviously behind, that now supports us on our path and supports our vision. So we closed a pre-seed round now with 2.85 million, and the partner that we at the end found, or that found us, or we found them, wherever we want to call it, but they are coming with a huge production background. So they are not a typical VC, but they are rather a company with multiple companies under them. And what they share is that they know how to scale a production technology, how to close multi-year contracts with huge customers. So they know our challenges that lie ahead of us. And that's kind of a great partner with kind of the same mindset of business that now supports us not only with the money that obviously is needed, but also understands the challenges and can help us there.
Okay, and that is inspiring to see that it's not just the typical startup VC and angel investor route, but someone who is really dedicated to the industry, or at least to the underlying production know-how. That gives trust that it's something really solid. That you're doing there. So on this expedition, I asked 3 questions to all the guests on the show, all the experts and leaders of our field. I want to start with a critical one, and that is the challenges that we see ahead of us, from your perspective, to build the European battery and e-mobility ecosystem. So who wants to answer that question on the challenges that, from your perspective, are holding us back? Jan?
Yeah, like one thing that I do think specifically in Europe is obvious that the industry and the core industry players that try to build up the cell production and the battery production, they are facing production issues, and that is their main challenge. And it's true, they need to solve this in order to scale up, deliver batteries that go into final products. But we will not win against the Asian competition if we only scale up. We also need competitive products, because the OEM and the final product and the companies behind those will choose the best batteries at the best prices. And that's why for us it's important that the industry in Europe, probably also in North America, has both challenges at the same priority level: scaling, but also the technology, the materials, the performance, and of course the cost level that is needed to have a competitive product on a global scale. Because only when both is achieved, then they will have a commercial success. So don't forget about the performance of the batteries and the materials that are needed for that, and the pricing that's needed for that.
Yeah, well, the price is, I think, a dependent variable on the technology innovation. I mean, that hopefully your technology also will enable to improve that situation. I see that, but it's a multifaceted optimization problem. Yeah. If we frame this positively, looking at the work that you do in this ecosystem of Europe, you mentioned research early on, like funding was involved. Now, like private funding is involved, like public funding, now private. What do you see as big potential levers that can bring us forward in Europe to build this ecosystem and succeed, as you just said? Yeah.
So I had a personal experience that I really liked. I was in Venice this year, on a battery conference where really major European players came together, and it was really the honest call to action of just, let's work together independent of any competitive situation, because bring in all the experience, all the ideas, to try to solve all the challenges, but like really connect with each other and work together, and don't create too much of competitive barriers. And I do think the talent and the ideas and also the experience in terms of production scale up, they are there in Europe. So we only need to work together and solve this. And if the industry is doing that, I do think we have really good chances. If they are building up any competitive walls, then it gets harder. So I do think that's a good call to action that was set there on this event, and I really think that this can help the European ecosystem.
Yeah, I think in alignment with that anecdote, I built up this campaign because I see it the same way. We have the competences, but we need to solve the how to connect those competences. So maybe to the final question, if there would be one advice that you can also answer both of you, that you would like to give all our stakeholders in the field, what would it be?
I think for me, it is really about, like what Jan said, we don't only need like batteries at scale and at low cost, but we also need good batteries, right? And if you want to develop a next gen batteries with a partner that is just providing like one little part of the big picture, like the most important thing I think is like to be open with each other and communicate, and not like try to cook in your own little pot and don't let anybody see what you're doing, because then also like we have many years of experience how to work with the graphene that we are producing, obviously from hundreds of projects with different customers in applications you cannot imagine in some cases, and but really what makes the real difference is like allowing us to also like bring that expertise to the customer and work together and be open with each other, like with feedbacks and things like this. So this is something that I can personally just say, that I think to innovate together you also need to like be open with each other and communicate, and that I think that is a big lever, as you said, that in some cases we've seen is probably underutilized, I would say.
Okay. Jan, you want to add something?
No. because I do think that that's really that's the essence of the experience at Saxonia. The companies that we work with closely, then we achieve something together, and then we can bring in a material innovation to a product. I saw no case where there was not an open conversation and discussion and sharing of information, and really also taking on challenges in the process that worked out. So without this openness and this collaboration, like bringing in the competencies and trying to solve something together, it will not work. So that's basically our biggest wish to everyone who wants to bring in our E-Graphene. Just be open, try to collaborate and solve or bring the innovation to life, but together.
Yeah,
I think that's exactly how I would end this discussion, because to collaborate together in order to build this industry. So Jan, Martin, thank you very much for the insights of today's visit, and looking forward on building this industry together.
Yeah, thanks for having us.
Yeah, thanks for
great.
coming.
Yeah.